Hello everyone, welcome to today's class. Today we are going to talk about sensors in robotics. So these are today's objectives. We'll be talking about sensing, just an introduction to it. Then we will list down all the different types of sensors that we can use in robotics. We talk about wheel encoders after that, and maybe in depth of how to make calculations for wheel encoders when you have the encoder count given, and we calculate the circumference and the diameter of the wheel required. Okay, so let's start with sensing. So what makes a machine and robot different? What do you guys think? Think about it. What can be the main difference? Now, because a fan is also a machine and a robot is also a machine. But what's the difference? They can think. But what just about that? They don't only think. After they think, they process information. But what information? Something which they can see, something which they can touch, something which they can feel. So basically sensors. Like we in humans, we have multiple senses like our eyes, ears, touch, right? The robots also have certain sensors, and it depends on us which and where we want to use them. So, what's sensing in general? It's basically detecting the information of the world, right? Now, these sensors look at this information and convert into a numerical value, something which you and me can understand, and which something we can use to make sense out of it. Like, if I have a distance sensor, I can detect that, okay, I'm at about 20 feet from that wall. So something like this, which robots can use in making their process better and make them smarter. Now, sensors work on transduction principle. Basically, it means conversion of energy from one form to another, right? So, sensors are also called as transducers sometimes. So, basically, in your textbooks or in online on Google, if you're reading something and if you look at words transducers, it basically means sensors. Now, what are some kind of sensors? How can we differentiate or classify between certain sensors? Now it's hard, right? If you just tell you that I want a sensor, that's difficult. Like what kind of sensor are you looking for, right? So we look into the classification of it. The first classification is called active sensors and passive sensors. Now what are those two? Now active sensors are sensors which basically send signal to the world and see how that signal is interacting with the world, how it's being manipulated in the world, and record that signal again. For example, imagine I'm a dolphin, one of my favorite animals, but imagine I'm a dolphin. I can send out ultrasound signals, and depending on the reflection or after how much time I get those signals back, I know the time difference, right? And that time can tell me how far is the obstacle. Basically, as being a dolphin, I can be an ultrasound sensor. I can send out a signal and I'm recording that signal again. So those are active sensors. The other kind is passive sensors. So something where you are not interacting with the environment, you're only recording what is present in the environment. For example, a camera. You can have a camera on a robot to see what the robot is seeing and basically to look for objects, to find for directions, to look for some cues, right? Or you can even use it to differentiate between colors and look for objects. So this is the first classification, active and passive. The next classification is the first type is exteroceptive sensors, which senses the environment directly. Something like passive sensors. So they can be for looking for objects or identifying a place. And for example, they are sonar and radar, like we discussed. The next is proprioceptive sensors. Basically, something which senses its own physical information, like how much distance have I traveled, how much rotation have I had, the current orientation, or let's say this is my robot arm, how much rotation I have had with the robot arm, right? So that's something of this type of sensors. And the examples, as you can see, is motor encoders and a gyroscope. A gyroscope is a device which can tell you whether you are balanced, your body is balanced, or whether you'll be falling down if you're not in the proper shape and position, basically your orientation. The next is interoceptive sensors. Basically, sensors which detect their own internal state. For example, your battery information. How much battery do I have left? Like if a robot wants to answer that, they need to have a sensor of this kind. And it can be done using a simple voltmeter that records the voltage value of the robot, of the battery basically. Now, what are some sensors? Like imagine, take some time and think about few sensors. What can you think about? Okay, take your time. Okay, so you already have few sensors on your mind. I'll discuss some and then we can talk about the rest. Just make sure you remove these which we already discussed so that we talk about some new stuff. So the first question when a robot asks, the most basic one would be, where am I? If the robot wants to know, what do? We use a localization sensor. Like shown in the picture, the robot is in a maze. It doesn't know its position. How can a robot know its position? For example, it can use a GPS, right? A global positioning system, which is already on your phone. A robot can also have it to know its own position in the world. Or it can have other kind of localization sensors. Basically, it can detect that pillar and say that, okay, I'm 10 meters away from that pillar. So it can be a relative distance as well. The next type is a normal robot vision. You have a camera on the robot and you have said that, okay, a human looks like something with 2 arms, something with 2 legs and a moving body. So you can program the camera accordingly and you can differentiate and the robot can know whether it's a human or an object. So you can have multiple algorithms to run on the camera to identify between different objects. The next is collision detection. So basically, am I going to hit something while I'm walking? Now it doesn't make sense that you're working so hard on making a robot and it goes into a wall and crashes, right? So we need to have some kind of collision avoidance. How do we do that? You can have a touch sensor over there. Basically, when I touch, it's a collision. Or you can have a wireless touch, something like an infrared to see, or like I explained for the dolphins, right? So basically, an active sensor. So you can use this sensor for determining how far is it from an obstacle. Now, one more thing is, how much distance did I travel? Now, I started from this position and I made this move. How much position did I travel? So that can be known through wheel encoders. It's basically a set of device which is attached with your wheel and it determines how much rotation of the wheel has been done and dependent on that, how much distance you are traveling. We'll talk about this more sensor ahead in the lecture, but let's come back to our other sensors. Now, did you guys think about anything else that you missed? Do you guys have anything? No? Nothing? Okay, how about temperature sensor? You want to detect if there's a fire in the house and you want to have a robot which will fight firefighting, right? So how can you do that? Using temperature sensor, right? Wherever the heat is max, you go there and you extinguish it. Now, we have already looked at the classification before. Of all these 4 sensors, which ones are passive and which ones are active? Yes, that was a clear thing, that the vision was a passive one and most of others are active because they are interacting using a signal with the environment and recording that signal again. Now, let's talk about motor encoders in depth. What are they? They are basically used to measure the rotation of the wheel, right? Rotation of the wheel can give us the distance traveled if we know the circumference of the wheel, correct? Now, rotation of the joint. What do I mean by that? Basically, imagine this is my arm. This is my arm, but this is a robot's arm. Imagine that. And this is the position 0. And the next position that the arm is at is this position. But now I want to calculate the angle that is the difference. So basically this angle, that I can do using motor encoders. Okay? So this can be used with the motors to precisely use the distance, to find the distance of the wheels traveled. Now imagine you have 2 wheels. You have two motors and two set of encoders. And the right wheel is going very fast, and the left wheel is going slower, much slower. So what will happen? You will turn towards left side, right? Now using these encoders, the count on the right wheel is more, but on the left wheel it's less. So you can say, just looking at those two numbers, that it's going in the left direction, right? So it's used even in the determining the orientation of the robot, correct? Now, what are the factors that affect wheel encoders? How the count of the wheel encoders differ? There are two major things. One is the diameter of the wheel. All wheels have different diameters, right? You don't see the same wheel that you use in a toy car and in your car, right? Obviously. So for the first is the wheel diameter. And the second is when the encoder is activated at a particular distance. Basically, in one revolution of the wheel, let's say your encoder is activated 16 or 20 times. That number is also essential to determine the circumference and the distance traveled. Now, let's take a look at a simple example where we find the wheel diameter. Now, what's given to us? Let's see. The problem is right here. It's given to us that the encoder's reading is incremented at each centimeter, at each 1 centimeter, right? So every time there's a distance traveled of 1 centimeter on the wheel, the encoder gives out tick 1. It's a +1, it's incremental. It keeps on adding with time. Now, the next given statement is 1 wheel revolution gives encoder value of 20 counts. So basically one entire revolution is equals to 20 count of encoder. So the encoder is activated for 20 times, right? Now, how do we calculate? So basically, you have 1 centimeter per count, and you have 20 counts in one revolution. If you multiply that, you get 20 centimeters per revolution. So the entire revolution will give you 20 centimeters. Now, this is not the diameter, be correct. It's the circumference of the circle, of the wheel. Now, if we know the circumference, we can obviously calculate the diameter, right? It's just circumference over pi will give you the diameter. And this is how you find the diameter of a wheel, if the counts of encoders are given to you, right? Now, this is it for today. But in the coming up lab in this week, you'll be testing more on infrared sensors. You'll be playing with collision avoidance. So make sure you enjoy that and make your good readings. Along with that, in the second lab, you will be determining and cross-verifying these calculations using actual wheel and actual encoder, and see if you're getting the same number on a meter scale as you're getting here in calculation. So thank you for coming today, and all the best for your coming labs. But do you have any questions before we set away? No questions? Okay, that's great. Please contact me if you want. Send me an email. Have a good day, everyone.